negative binomial, right? Are you all here?
Yes, madam.
Yes, madam.
Alhamdulillah, thank you very much for the answer. So let me enlarge this. Okay, let's look at the properties of geometric random variable. Okay. Yes, of course, it is discrete. When I say discrete, it has to be countable, separate, distinct. Okay. So you can count one by one. And yes, we have trial. Okay, in geometric distribution or for a geometric random variable, where the trial has only two possible outcomes, success or failure. So you have to be very clear which one is, are you talking about success or are you talking about failure? Okay. And here we only have one success. Okay, one success. Unlike negative binomial where you have R successes, okay, more than one, here you have R equal to 1. Okay, so when R equals to 1 in negative binomial, you have this special random variable, we call it as geometric. So let's look at the definition of your random variable x. We define x to be the number of independent trials. Okay, the number of repeated trials. So you need to be very clear what is your trial. Okay, uh, and you keep on repeating the trial until you get the first success. Okay, or sometimes you can have until the first failure. So the keyword here, until the first. Until the first success or failure is observed. So if you remember just now when you had negative binomial, you have RP. Okay, the parameters R and P. But here R is 1, so another way of writing the distribution, okay, will be geometric. Geometric, which is depending on the P value. What is the P value? P is the probability of success when you define X to be the number of trials until the first success. If you define X to be the number of trials until the first failure, then P has to be the probability of failure. Okay? And that probability of failure is constant for all trials. Okay? So here again, your R starts with 1. So that's the value of X has to start with 1. Okay? The probability function, if you recall the probability function for negative binomial, and then replace the value of R with 1. Okay? Then you get this probability function. Okay? Remember, probability function means you have probability of X equal to a particular value. And remember last time in negative binomial, you should have x minus 1 choose r minus 1. Imagine r is 1. Okay, so you have x minus 1 choose 1 minus 1, which is 0. So anything choose 0 should be 1. So you don't have to worry about the combination. So the multiplier at the front there is 1 times p. It should be p to the r, but you know r is 1, isn't it? So you have p times 1 minus p to the x minus r, but r is 1. Again, you have 1 minus p to the power of x minus 1. So this is geometric probability function. And you know x values go from 1 to 3 and so on until infinity. Okay, so this is also an infinitely countable example of a random variable. Okay, so the expected value For negative binomial, in general, you have R over P. Now, R is 1, so you just replace R with 1. So, EX for geometric random variable is 1 over P, whereas the variance is simply 1 minus P to the divided by P squared. For negative binomial, last time you had R times 1 minus P over P squared. Now, R is 1, so you're left with this expression for the variance. Again, you have the statistical table to help you to recall the expected value and the variance for this particular random variable. Examples of geometry and variable. Okay, if you can recall just now in our activity in Padlet, you can see a number of examples where your friends put until the first success or until the first failure. So those are actually geometric. It's still under the same family as negative binomial. We call that as a special negative binomial case where r equals to 1. So if you can recall what you did learn from the recorded session, you have this exactly the same example, but we changed to the repeated trials, okay, until the first failure. For example, in this case, you had the number of complaints received until the third complaint last time. Okay, so this time we have until the first. So you have geometric random variable. The number of patients checked until the first diabetic patient was observed. So again, you check. The trial is checking the patient one by one until you get the first patient that you check is a diabetic patient. Okay? Until the first. That is the keyword. Until the first. Next, the number of batches checked. You check the batch, the batches produced by your company, for example. Okay? One by one. Until you get the first batch which is defective. Okay, so the trial is checking the batches of products, for example, until you get a defective batch. Okay, so that is geometric. Okay, until the first. So that is the keyword. So if you look at task 1.5, page 25, we do have this question. The probability that a computer running a certain operating system crashes in any day is 0.05. Okay, so you want to find the probability that the computer crashes for the first time. So that is the keyword, the first time, on the 10th day after the operating system is installed. Okay, so obviously you are talking about a random variable uh, where the trial here is the computer, okay, which is running. Okay, day one, uh, the computer operating system was okay. The second one was okay. The second day was okay. The third day was okay. Suddenly, on the 10th day, that's the first time the computer crashes. Okay, so you can define a random variable which follows a geometric random variable, geometric distribution. That's the first question. Whereas the second question, you are to find the expected number. Okay? You're not talking about finding probability anymore. This is the expected number, the EX, the mu. Okay, for a geometric random variable. So let's look at how you can solve this. First, again, always define your variable. Okay, here you can possibly define X to be the number of days the computer runs until it crashes for the first time. Okay, so you look at the number of days the computer runs one day after another, and you observe the days one after another until it crashes for the first time. So the crashes can happen on any day. Maybe the first day it can crash. The second day, it can also crash, and so on. Okay, so then here you have the probability of crash on any day is 0.05. This is information which is very important for you to know, which define the distribution. Okay, so then X is geometric, with probability 0.05. Okay, so define the variable, get the information required to define the distribution, and write down the distribution. Okay, and if possible, write down the possible values of X, so that this will help you later if you want to find the probability related to X. Alright? So, what do you want to solve? The probability that the computer crashes for the first time on the 10th day. And the keyword is the first. So that happened on the 10th day. So just imagine you have day 1 okay, day 2 okay, day 3 okay, and all the days until the 9th day was okay. Okay, so the probability related to those days are 0.95, isn't it? So you have 0.95 times 0.95 times 0.95 and so on until the 9th day. And suddenly on the 10th day, that's the first day the computer crashes for the first time. So of course, on the 10th day, the probability will change to 0.05. Okay, so here you have Px equals to 10. Okay, crash on the first time on the 10th day. So the probability, if you use the probability function just now, this P, okay, is actually P on the 10th day. Whereas the other 9 days, you have 1 minus P to the power of 9. Okay. So what is your answer if you replace P with 0.05? Can you write down your answer, please, in the chat room? 0.0315. Okay, thank you very much. Fahmi, Shafiq, Nabil, Afiq, yeah? Farabi. Farabi, what's your answer? Okay, so we'll look at this answer. Yes, 0.0315. That's how you write down the answer, yeah? But the challenge for some students, how to rephrase the question here, the question into mathematical expression. Okay, this is the challenge, because if we give the students this question right away, of course the students can answer directly. But when it comes to the sentence like this, to translate this sentence into the mathematical expression, that is the challenge, a big challenge. But I believe after some exercises, you get the idea. You get the idea. But above all, you need to define your variable first, identify the suitable distribution, okay, identify the information given, write down the distribution for possible values of x, and then rewrite the question into mathematical expression like this, and then make use of the appropriate function and get the answer. That should be the steps in answering any probability question related to particular random variable. Now, the second one, the expected number of days the computer runs until it crashes for the first time. So you're not talking about finding a probability. You're talking about finding the expected number of days. So the expected number is actually the mean, the EX. Sometimes some students do not know what is that expected number. The word expected, that is the mean, yeah, the mean or the average for a random variable. So notation is EX. Okay, EX. For geometric random variable, it is 1 over P, and you know P, replace that P value with 0.05, then you get 20. Okay, so that is the answer for this particular question. Right, basically, we finish on negative binomial and geometric random variables. You learned the negative binomial before, and today you have geometric random variable. These two are coming under the same family distribution, where geometric random variable is a special case of negative binomial when the R value is 1. Okay, so you should by now be able to identify the properties. Do you think you can identify the properties of these two variables?
Yeah.
Yeah, that's great. Write down the distributions of the negative binomial. Remember, for negative binomial, you have X to follow negative binomial with R and P. Okay, you have to know R, you have to know P to define the distribution. Whereas for geometric, you don't have to worry about R because R is automatically 1, and you can just write down geo with P. Yeah? But if you want to write down like NB, negative binomial with 1 and P, that is also okay. Once you know the distribution, of course, you should be able to write down the probability functions. And those are available in the statistical table booklet. And once you know you have these variables, then you can look at the probability functions in the statistical table. Okay, and you should also be able to calculate the probability related to negative binomial by using their probability functions. Negative binomial and geometric random variable. Okay, here again, you do not have the cumulative negative binomial probabilities or cumulative geometric probabilities in the statistical table, unlike binomial and Poisson. So in order for you to solve probability questions related to these two random variables, you have to use probability functions only. Okay, so if you have, for example, px less than 3, for example, okay, for geometric random variable. So how do you work out? If you have x, okay, to follow geometric with say 0.1. So how do you work out px less than 3? How do you do this? Anyone? Hello? Yeah, Fahmi Yasir said px equal to 1 plus px equal to 2. That's correct. And well done, Fahmi. Sham also agree with Fahmi. Well done. But Shafiq, we don't include x equal to 3, okay? Why? Less than 3. Less than 3 means 3 is not included. Remember, this is discrete, yeah? Discrete. So 3 is not included. Why is not 0? Your friend asked us here. Faris Alani asked, why is it not 0? Anyone can answer that? Why is it only 1 and 2? You plus px equals to 1 plus px equals to 2. Why is it not 0? So this is Px equals to 1 plus Px equals to 2. Only. Why is it not 0? There is no trial if x equals to 0. That's Fahmi answer, yeah? Because there is one success, yes. Positive integer, yes. 0 is not trial. Okay? Okay, x must start from 1. Yes, that's correct. X starts from 1. Okay, remember, that's why you have to know the possible values of your random variable. For geometric, you start from 1. You don't start with 0. So when you have x less than 3, it really means x equals to 1 or x equals to 2. Okay, you don't include 0. Well done. Your friends already answered the question correctly. Okay, so again, you always have to rephrase your question, okay, into probability of x equal to a particular value. You make use of the probability function. You don't use the cumulative distribution function directly because you don't have the table given to you. Okay. All right. Hold on. Okay. So next, obtain the expected value and variance for a negative binomial and geometric random variables based on the given formula. Do you think you can do this? Can you achieve the fourth learning objective? Should be okay, right? Yes. Yeah, because it's direct from your statistical table. As long as you know what you have is geometric random variable or negative binomial random variable. And last learning objective is very important. Okay, you won't be able to achieve the second, the third, and the fourth learning objective if you don't recognize that the variable follows these two distributions. Okay, so you have to have the skill of recognizing the uh, the variables from the real applications. Okay, so I can see just now your group demonstrate a very good understanding on these two variables. Okay, uh, for negative binomial especially, and then if you take the special case until the first success or until the first failure, that is geometric. So you can identify when you can write the example, it shows that you can recognize these distributions from real applications. Is CDF for NB exists? Yes, it exists, but it's not available in the formula booklet. It exists. It exists for all variables. CDF is simply probability of x less than or equal to a particular value. Okay. However, this CDF is not available directly from your statistical table. You have to calculate from the probability function. Okay? Fahmi, are you okay? Do you get what I mean or not? Fahmi? Unlike binomial and Poisson, where you are given the CDF values in the table, so you can get the CDF values directly from table. You don't have to calculate one by one. But for negative binomial, and later on for hypergeometric, you have to calculate the CDF based on the probability function. Okay, you have to use the probability function to work out the probabilities. Okay. Ayman asked, if R equals to 1, is it automatically becomes geometric distribution? If R more than 1, it will be negative binomial. Yes, that's correct. Geometric is when you have R equals to 1. That is a special case of negative binomial. But in general, you have R more than one. So we use negative binomial in general, which is depending on the value of R and the value of P. But if R equals to 1, it is automatically geometric. Okay, or simply negative binomial with R equals to 1 and P. Okay, the same thing. Okay, but for geometric, you don't have R more than 1. R is 1. Okay, Aiman, are you okay? Aiman?
Yes, madam.
Okay, Alhamdulillah. Very good. So basically, we finish with this variable, especially on geometric distribution. Okay, so we will go into hypergeometric shortly after this. Okay, so stay put. Okay, I'm going to change the slide